and the recording just started. So let me share my screen just to provide you with quick overview of the aim, the scope, and the framework of this webinar. I hope everyone can see my screen. All right. So just to introduce a bit myself, I'm Thomais Vlachogianni. I am a Senior Program and Policy Officer at the Mediterranean Information Office for Environment, Culture and Sustainable Development. And for those of you who don't know, my organization, MIO, this is a federation of environmental NGOs from the Mediterranean. And we as an organization, and me personally, have been working on the topic of marine litter for more than 10, 15 years. And today's webinar is actually part of an e-course that has two tranches. The one is focusing on marine litter monitoring approaches to assess the presence and effects of marine litter. And the other, on the 19th of January, I hope to see you all there as well, will focus on measures to prevent and mitigate its effects. And this e-course is organized within the framework of NECBC project entitled Plastic Buzzers, CAP, and also by MIO and the University of Siena, in cooperation with another Mediterranean project funded by the EU that it's entitled Water and Environment Support in the ENI Neighbourhood South Region project. All right, so what is today's topic, the topics that will be addressed in this webinar? So first of all, this webinar has been designed in order to enhance your capacities in designing and implementing a comprehensive marine litter monitoring strategy. And therefore, the different topics that we will be touching upon are related to macrolitter and microlitter monitoring. Macrolitter are items larger than 2.5 centimeters, and microlitter are items smaller than 0.5 centimeters. And we together are going to go through the different methodological approaches to survey marine litter on beaches, on the sea surface, on the seafloor, and in biota, with the ultimate objective through these monitoring approaches to generate fit-for-purpose data, data that are comparable, and data that are reliable. And this is just the agenda overview. I will not go into details, but as I already mentioned at the opening, we have envisaged after each presentation a Q&A session where basically we will try, together with the speakers, we will try to respond to your questions that you can post in the chat throughout the different presentations. You can also post questions in Arabic. If, of course, in English it would be much easier for us, but we have the interpreters with us that can help us with translating the questions in Arabic. And in case we have an overflow of questions, obviously we will not be able to address them within the scope of the webinar, but we will provide written replies after the completion of the course. And here are the speakers of today's webinars. So already I introduced to you Maria Cristina Fossi, who is a university professor in the University of Siena on ecology and ecotoxicology, and she's a world-known expert when it comes to her research on marine litter, in particular marine litter effects on biota. And together with us today, we have three members of her wonderful team. We have Cristina Panti, we have Dario Gianni and Matteo Baini, who have been working with her for many years now on research and monitoring of marine litter, with a special emphasis on the effects in biota. And regarding this e-course, we have been delighted. In fact, the number has increased since I prepared the slide. We have been delighted to have 383 registered participants. I see that here today we are already 115, and I'm sure that more will join throughout the webinar. And the majority of the participants are coming from higher education institutions and the research sector, but also we have people from NGOs, from local authorities or national authorities, and from education and training centers. And here I would like to pass the floor to Cristina, and she will provide you with some more information regarding the framework of this e-course and the wider initiative that this e-course is being implemented. So Cristina, the floor is yours.
Thank you very much, Tommy, for the very nice introduction of the courses. And as probably you know, we are involved in the last decades in this adventure with MIO, and particularly with the Thomais, try to binding together the North and the South Mediterranean Sea in a common approach in terms to monitor and mitigate the impact of marine litter. This adventure and initiative has a funny name that is Plastic Busters, and that initiative was born more than 10 years ago in the University of Siena under the umbrella of the United Nations with the SDSN network led from Siena, and have a very long story with a lot of achievement and endorsement, and especially in 2016 we received the label from Union for Mediterranean as a flagship project that have this novelty to merging together the North and the South Mediterranean Sea in these fights. Today, we have the great pleasure to have one of the main activity of one of the, I can say, daughter project of this initiative called Plastic Buster Cup, that, as mentioned from Tommy before, is supported from the European Commission in the ENI CBC framework, and have the great opportunity to capitalize many of the experience that we develop, in particular with the Plastic Buster MPA's initiative, that is another great project support from the European Commission, and that project that we see here is was really the born phase of all our activity, in which you can say we explore the different phase of the complete SARC activity in terms of monitoring, mitigate, disseminate the topic of marine litter Mediterranean way. But what we intend to do in the Plastic Buster Cup is capitalize the activity of this project, especially in the two main phases that will be the monitoring approach, that will be the main subject of the training today, and the consequential diagnosis that produce the second important phase, that is the mitigation approach, that will be present in the second day of this training. So that is more or less what we expect to have all of us together in the main goal to try in the Mediterranean basin to have the same language for monitor and mitigate the impact of marine litter in our marvelous sea. Thank you very much for your attention, and I pass the floor again to Tommy.
Thank you, Cristina, for providing a little bit of information on the context of this e-course. And obviously, after the e-course, we are going to share with you materials where you can dig deeper into the different aspects, including the framework and the project within which this e-course is being implemented. And now, without losing any time, I would like to move on to the first lecture of this webinar that is focusing on the monitoring approaches for macrolitter in the coastal and marine environment. And as I already mentioned, please feel free throughout my presentation to post any of your questions, any kind of questions, don't be shy, in the chat. So,
Tommy, can I ask you for a favor? Can you please record the presentations?
first of all, I'm really sorry, but I didn't understand. But
I mean, recording the presentations.
yes, the recording of the presentations has started.
Okay.
Okay, and kindly please mute yourselves because we don't have a lot of time to make live exchanges, and use the chat in case there is something that you would like to request. So thank you, Fuad, though, for highlighting this. So moving on. Okay, let me put this here. All right. So first of all, we will be touching upon marine litter monitoring within the wider scope of the management cycle of marine litter. And the idea is here with appropriate monitoring approaches to generate fit-for-purpose data in order then to facilitate the identification of feasible and effective solutions that will lead to coordinated actions. So kindly keep in mind these different steps, different phases of addressing the problem of marine litter, where the understanding of the problem is a crucial aspect in terms of identifying the needed solutions. So let's begin with a few definitions that will be useful in order for all of us to have a common understanding of the different aspects of the problem of marine litter. So first of all, as monitoring, we define a long-term standardized measurement, observation, evaluation, and reporting of the environment in order to define the status and trends. So in order to define whether the environment is in good environmental status, and also in order to understand whether, for example, the type of pollution, in our case, marine litter, the type of pollution that we are monitoring is either increasing, decreasing, or is stable. And so for marine litter monitoring, the idea is to elaborate information on the types, quantities, distribution, and impacts, to identify the sources of marine litter, and to assess the effectiveness of management measures to address the issue. So kindly please mute yourselves. So key terms and definitions. First of all, what we define as a survey. The survey is the process of recording data related to a sampling unit at a given time. These key terms and definitions will be used throughout the webinar, so keep them in mind, because even within the circles of scientists, oftentimes there is a bit of confusion when it comes to these terms. A survey site is a section of a coast, sea surface, or sea floor, or a location where one or more sampling units are being chosen to be placed. A monitoring campaign is a long-term process of carrying out one or more surveys in one or more survey sites with a certain frequency and within a given time period. And a monitoring method is the detailed description of the procedural method, the actual protocol for monitoring marine litter pollution, including a classification list of litter types. And today we will be focusing mainly on macrolitter, which, as I already mentioned, these are items larger than 2.5 centimeters in the longest dimension and with no set upper limit, and microlitter, which are items smaller than 5 millimeters or half centimeter in the longest dimension, with no set lower limit. And unfortunately, to date, there are not unified, harmonized approaches for mesolitter, which include the items from 5 millimeters to 25 millimeters in the longest dimension. But this is something that different scientific and policy groups are currently working on in order to come up with a harmonized protocol. And even though I know that many of the participants are coming from different parts of the world, not just the Mediterranean, here I just wanted to provide a little bit of context when it comes to the methodological approaches presented through this webinar. And the policy context is framed basically at European level by the Marine Strategy Framework Directive, the Plastic Strategy and the Single-Use Plastics Directive, and within the UN policy context by the Barcelona Convention and the Ecosystem Approach and the Regional Plan for Marine Litter Management in the Mediterranean. I will not go into details, but most of you who are active in the Mediterranean region are aware of these legislative frameworks. But I would also like to stress that the leading group in terms of all developments related to monitoring marine litter is a European group that is called the Marine Strategy Framework Directive Good Environmental Status Technical Group on Marine Litter, that has been doing pioneering work in terms of consolidating the knowledge base for marine litter and for marine litter monitoring in all European regional seas. And in fact, is providing constructive input to all international related science and policy fora. So what we will be addressing here today with my presentation, we will be talking about the methodology for monitoring macrolitter on beaches, for monitoring macrolitter on the seafloor with visual census, monitoring macrolitter floating on the sea surface, again with visual census, and monitoring macrolitter by using bottom trawl surveys. And one of the most important policy advances that is sort of a breakthrough when it comes to marine litter monitoring on beaches has been the identification of European threshold value, which is smaller than 20 litter items for every 100 meters of coastline, and this value defines whether good environmental status has been achieved on the coastline. To my knowledge, correct me if I'm wrong, this is the first of its kind threshold value that has been set at international global level. And currently the group, this European group, is working on identifying threshold values for macrolitter in other matrices. And another important breakthrough of this group has been the elaboration of the joint list of litter categories. In fact, there had been a list, the so-called the master list, that was adopted in 2013 and was applied not only by European countries, but also at global level. But in 2021, we have further refined this master list in order to include all the feedback from the different marine litter surveys carried out at European regional seas. And we are happy to have now the most refined version, the so-called joint list, and also to have a manual, a detailed manual for the application of this classification system. This list is applicable for all marine compartments and for beaches and for the sea surface and for the seafloor and also for biota when it comes to macrolitter. And one of the innovative elements of this list is that this list has been structured in a hierarchical way in order to allow the comparability of results of data obtained with different lists that deploy a different level of detail. So the hierarchical structures follows 5 levels. At the first level, we have the material type. So macrolitter items can be classified as artificial polymers, can be classified as paper or cardboard, textile, glass, can. And then the second level is related to the use, and I will come back to that in my next slide. The third level goes into further detail, and we specify there, for example, in the case of food consumption related items, whether this is a bottle and container or whether this is tableware. And then at the fourth level, we can go even further to have specified a different type of a container, whether this is a drink bottle or whether this is a food container made of foam polystyrene, and even more to go at the fifth level, where we specify the size or the volume of this litter item. And of course, this high level of detail that for some of you might be something new is required in order to be able to understand the exact human-induced activity that generates this litter, in order then to be able to take tailor-made action and to make a targeted intervention. So coming back now to the use categories, the following categories have been defined. We have items that are agriculture related based on the primary use, aquaculture related, it can be clothing, building and construction related, food consumption related, fisheries related, personal hygiene and care related, medical related, recreation and tourism related, smoking related, vehicle related, and hunting related. And obviously we have also one category that is entitled undefined, that relates to a use that cannot be restricted to one of these uses that have been mentioned here, meaning that this item can be used in multiple ways, in multiple sectors, so it is not possible to pinpoint it into one specific human-induced activity. And this is how the list looks like. All of you will receive this list and the manual for its application. So I will not go to further details, but just to give you an overview. And the list with the items in the sixth layer are 183. And this is in fact the highest level of detail that can be recorded with a joint list, and this greatest detailed list is entitled the J-code list. And also, in order to facilitate practitioners' effort, we have developed an online photo catalog with images of these different items included in the J list. I say we because I happen to be also a member of this group that has elaborated this work. And now, going straight to the methodology for monitoring macrolitter on beaches. In fact, the key elements of the methodological approach are clustered into the monitoring strategy and in the survey protocol itself. The monitoring strategy consists of the site selection criteria, the frequency and timing of the survey and the sampling unit, and the survey protocol defines how the litter sampling should be performed, the litter size classes and classification system to be deployed, and the litter removal and disposal approaches. So regarding the site selection criteria, a lot of these criteria are relevant for all types of marine litter monitoring that you will be hearing today throughout this webinar. And for beaches in particular, we are including sites that are in the vicinity of ports or harbors, sites that are in the vicinity of river mouths or coastal urban areas, in the vicinity of tourist destinations, and also in relatively remote areas. On the one hand, in order to see whether these remote areas have been impacted, and on the other hand, using these remote areas perhaps as reference sites. And in order to be able to generate comparable and reliable data, these different sites need to be characterized by specific features. For example, the beaches need to have a minimum length of 100 meters, to have a low or moderate slope, a clear access to the sea, to be accessible to survey teams throughout the year, and also ideally not to be subject to cleaning activities, even though there are ways to overcome this. And most importantly, the survey sites should not pose any threat to endangered or protected species. And here also I would like to add that the beaches need to be either sandy beaches or beaches that have relatively small pebbles. So here are some examples of sampling locations in the Mediterranean. And here is the classification of the different beaches based on some characteristics related to the environment that these beaches are located, their accessibility, the habitation and accommodation, and the services that and facilities that are on the beaches. And these beaches are classified either in urban, semi-urban, and remote, natural, depending on the type of specifications that they have in accordance with this table. Regarding now the frequency and timing of surveys, surveys should be conducted in the 4 seasons of the year: in autumn, in October, in winter, in January, in spring, in April, and in the summertime in July. And the data from this seasonal monitoring are being used in order to calculate the means and the averages of the litter densities, because in order to survey the seasonal variations, which for monitoring purposes are not so interesting, but even, let's say, in some cases, this would be interesting for research purposes, for example, then the seasonal monitoring of litter has to be conducted over consecutive years in order to be able to establish a seasonal variation of litter densities. So regarding the sampling unit is defined as a 100-meter stretch of beach along the strand line, and it reaching all the way back to the beach. So obviously, depending on the type of beaches, whether the beaches are very have a big width, the size of the sampling unit can be it obviously will differ, and the only thing that will be fixed will be the stretch of the beach that will be 100 meters. And one difficulty here might be to define what is the back of the beach. Okay, for example, the back of the beach is identified using coastal features such as the presence of vegetation, the presence of dunes, the presence of cliffs or a road or a fence or any other anthropogenic structure such as seawalls. In the case on the right-hand side example, you can see that the end of the beach is defined by the presence of vegetation. And here, for example, you can also see that is defined by the presence of trees and vegetation. So one important consideration when choosing where to place the sampling unit on a big beach, you have to always keep in mind that the sampling unit needs to represent the general characteristics of the survey site and the general state of litter in the survey site. So, for example, the sampling unit should not be placed on the edges of the beach or on parts of the beach that have a higher potential to accumulate litter. And in fact, here there is an example of how to select randomly in a beach where to place the sampling unit. So in this example, you can see that we have a long beach that has at least 1, 2, 3. It has around 10 100-meter stretches, all right, which are represented by the letters A, B, C, D, E, F, etc. And obviously, if we divide the coast into 100-meter sections, we are going to exclude from a potential location for the sampling unit the section A, that is at the edge of the beach, where the beach becomes narrower and it would most probably have a higher chance to accumulate litter. We are going to exclude the section L that is located in front of a hotel, because this is not the representative picture of the beach. And also we would exclude the section G, which is located in front of the entrance of the beach, where potentially it could be also the parking lot, where a lot of litter items oftentimes are being dropped, and there would be a tendency to have higher litter densities. So from the remaining sections, we choose randomly where to place the sampling unit. Of course, when we experience heavily littered beaches, like the example presented here, it's very difficult to survey a 100-meter stretch of beach, because this would require more than 1 day of work. And it would require a high number of surveyors, maybe 6 to 8. Typically, 3 to 4 people are involved in beach litter monitoring activity. So in that case, if we have a heavily littered beach, inevitably we will have to survey a smaller sampling unit. And the first option would be to have a 50-meter stretch of coastline. Here, the problem is that if we would dramatically decrease the length of the stretch of coastline to survey, we might compromise the representativity of the sample. And therefore, ideally, we wouldn't want to go lower than 50-meter than a 50-meter stretch of beach. And obviously here, when the results are reported, this should be normalized to a 100-meter stretch in order to be comparable with results obtained from the typical monitoring protocol. We discussed about the different size classes. When we talk about macrolitter monitoring, we talk about items that are 2.5 centimeters in the longest dimensions, but also include some items that are closer to the 2 centimeters. So they're marginally within the mesolitter size class. And these items are plastic cups and cigarette butts. And as I already mentioned, we don't have a harmonized protocol for monitoring mesolitter items. However, in the case of high numbers of plastic cups and high numbers of cigarette butts, a sub-sampling of the sampling unit can be performed, meaning that from the 100-meter stretch that we will have used to survey the entire beach, we can survey these items in 3 randomly placed 1-meter transects, and then calculate the mean or average densities. And regarding the sampling approaches and how to collect the litter items from the sampling unit, here you can see different routes and paths that the surveyors can follow, either working vertically or in parallel to the strand line, starting from the same point or meeting in the middle of the transect, 100-meter transect, and so on and so forth. And regarding the litter items classification, this can be conducted either on site. And here you can see my friend Cristina doing the on-site classification in accordance with a joint list. This is actually the optimum approach, simply because litter items, when transferred away from the site, they can fragment in smaller bits and parts, and this can lead to an overestimation of the litter density. But when that is not feasible, perhaps due to weather conditions, then the litter items can be transferred to the laboratory or to the office, and they can be classified there. And this is more or less how things look like on the field. After many years of experience, we have realized that classifying the litter items when they are picked up is a very time-consuming process. So usually what we do is we collect all litter items in 1 or 2 spots of the transect, and then we, in fact, we sort them in different groups. So we put all the cups together, we put all the plastic bottles together, and so on and so forth, in order to speed up the process. So this is one of the most important field tips, because if we are talking about relatively littered beaches, declassification can take many hours if some of these tips are not used. So also, in the case that we cannot avoid but transferring the litter items to the laboratory, in order to avoid the overestimation of those litter items that fragment, we can actually classify, record those that fragment on the coastline, and take back to the laboratory or to the office the rest of the litter items. This could be an approach. As I already mentioned, it's helpful to first group items in litter categories and get over and done with the plastic cups, the plastic bottles, and then spend more time for the more special, let's say, litter items that require some thinking in terms of classifying them in the joint list. And also, it may be the case that some litter items might not be recognizable on the field, and they can be either photographed or they can be taken back to the laboratory in order then to explore and try to identify and classify them. And some additional considerations are the following. First of all, it might be the case that in fact, here is a beach that normally is super clean. But it was the case that in one of my visits, I experienced this kind of situation. And obviously, monitoring this beach and considering these results in the calculation of the mean or average litter density might have led to an overestimation. So when there are extreme weather events, the litter surveys should be avoided. And because obviously they will not give us the representative picture of the beach. And other consideration could be difficult weather conditions or different replenishment and nourishment activities on the coastline. All of these considerations should be taken into account, and ideally exclude measurements when these kind of conditions apply. Regarding the materials and equipment, these are very I would say robust and simple items that can be easily purchased. So this is a high-resolution camera, and for documenting the survey site, but also for documenting some specific litter items, a handheld GPS unit, and 100-meter stretch measuring tape, flag markers to define the sampling unit, rubbish bags, protective gloves, some rigid containers in order to collect perhaps sharp items, such as needles, clipboards, recording sheets, and you're all, if you have these items, you're set and ready to go. So this is the approach for monitoring macrolitter. And now we will move on, macrolitter on beaches, we will move on to the sea surface. In general, you have to keep in mind that the principle is the same. It is just that the environmental medium is changing. And of course, some adaptations need to be made in order to be able to apply the same approach at sea. So, for example, when we're talking about sea surface litter monitoring, obviously we cannot collect the litter items because we are on a vessel. So, and obviously we don't have as much time for the classification because we are moving. So we need to keep this kind of specificities in mind and try to see how that could be done at sea or at the seafloor. So regarding the site selection criteria, similarly as to macrolitter, we are choosing different areas exhibiting potentially different litter densities. So we can have low density areas like the open sea, high density areas close to ports and marinas, close to tourism and recreational activities, close to cities, and other selected areas of interest, for example, in the vicinity of estuaries or riverine outflows. And regarding the period for floating macrolitter, basically it has been agreed that these surveys will take place twice per year, in the springtime in April and in autumn in October. And again, the mean and averages will be calculated. And in order to do that, as you can see on the right-hand side, there is an observer that is sitting in the front, or two observers sitting at the front part of the vessel, and they are surveying a certain transect with a certain width on the right hand or the left hand of the boat while the boat is moving, and the distance that the boat is making is defined as the transect length. So here the trickiest part is defining the transect unit. So defining the transect width and the transect length. So depending on the size of the vessel, whether the vessel is big or small, and how far is the observer elevated from the sea surface, it has been agreed that either 3 meter or 6 meter transects could be deployed, and or even 10 meters in the case of larger vessels, and the transect length should correspond approximately to 1 hour of observation, with the boat moving with a relatively small speed of 4 to 6 knots. And here, in fact, let's see if this video will work. Unfortunately, it doesn't work. I don't know why. Anyway, you would see here Matteo, who is sitting in the front part of the vessel, and he is surveying litter items floating on the sea surface and classifying them on the joint list. So this is also another idea of how things could look like. We could have 2 observers looking at each side of the vessel, and therefore increasing the size of the transect of the sampling unit. And here, first of all, what I would like to mention and to highlight is that it seems relatively straightforward, but there are some small technicalities that should be considered. So, for example, how to always keep fixed the transect width. Okay, so an idea could be that, for example, a fishing rod is placed on the side of the vessel with a fixed width of 3 meters or 5 meters, and then the tip of the fishing net that is hanging from the fishing rod could be slightly touching the sea surface and always indicating where the transect width is ending. This could be an approach, or another approach could be to have a fixed piece of wood or metal placed on the sides of the vessel in order to always keep the transect width fixed. And also what should be avoided is, as you see here, we are doing a training on floating litter monitoring in Croatia, and on this side of the vessel we have the glare from the sun. So this is obviously not ideal for doing the macrolitter monitoring, and therefore the side of the vessel that there is the glare of the sun should be avoided. In general, the floating litter monitoring should be performed when the conditions for visual observation are optimum. So we are talking about the sea surface to be calm, and for example, days with mist obviously are not a good idea to perform this kind of an activity and to avoid the sun glare. And so regarding the materials and equipment to be used, similarly as for for beach macrolitter, a camera, a handheld GPS unit, recording sheets, and maybe binoculars, because in some cases they might be useful in identifying the litter items. The trickiest part when monitoring a floating litter is that in an ideal universe, the litter would be floating just above the sea surface, and it would be very easily visible what this is, and the boat would move relatively slow, so we would have time to put it on the list, and so on and so forth. But in reality, many times litter items are submerged into under or partly under the sea surface. Maybe there is an accumulation of litter items, which means that we have to see very fast and try to record quickly the different categories of litter items. Plus, in addition, that unlike the beach litter monitoring, we need also to classify the litter items in different size classes, which makes the work for floating litter a little bit more difficult on the one side, but on the other side, typically the litter densities for floating macrolitter are relatively small. Let's say typical densities are 3 to 5 items per square kilometer, meaning that in typical locations, the chance to see floating litter items is relatively small. Let's put it like that. Regarding now the monitoring of macrolitter on the seafloor with visual sensors, again, these are the timings that the survey should be performed in spring and in autumn, April, October, respectively. And the idea is that we have a sampling unit, the same as on the beach, but in this case is located placed on the seafloor, where the surveyors are collecting the different litter items, and they're bringing them ashore and doing the classification in the exact same way as we do for beach litter. Obviously, some heavy objects cannot be removed from the seafloor, and these have to be either photographed and then classified when ashore, or they can be classified on the spot. So this is how a sampling unit on the seafloor looks like, very, very similar to the one located on the beach. We have a transect width and we have a transect length, and depending on the different environmental conditions, whether there is a low turbidity or high turbidity, and depending also on the litter density, whether we have small litter densities or high litter densities, the sampling unit can differ, and it can be from 20 by 4 meters to 100 by 8 meters or to 200 by 8 meters. And typically divers are working in pairs, surveying different sides of the 100-meter transect that is defined with a measuring tape that is being placed on the sea bottom. And the results are expressed in items per square kilometer, similarly as to floating litter items. And as already mentioned, the joint list is again used to do the litter items classification. And on those images, you can see some typical litter items found at the bottom of the sea: fishing ropes, bottles, fishing nets, one small bicycle. This is not so typical. And or on this photo, you can actually see the types of items that were brought ashore by divers in one of the surveys that was performed in the Mediterranean. And regarding the materials and equipment, in addition to what is being used for beach macrolitter and for sea surface litter, a mesh sack is needed in order to transport the litter items from the seafloor. Then some ropes to be used underwater in order to define the sampling unit, and some waterproof recording sheets in case litter items need to be classified within the water. And lastly, regarding the methodology for monitoring macrolitter on the seafloor with the use of bottom trawl surveys, in case these bottom trawl surveys are allowed, this is in fact a more opportunistic approach in the sense that we don't use trawlers in order to go and perform marine litter monitoring, but the reverse. We actually use typical trawling operations for fishing purposes in order to collect some valuable data regarding marine macrolitter. And this is in fact, of course, in order to do that, we need to have to collect this data in the agreed timings. So again, in spring and in autumn, we need to have data that correspond to different trawling depths. And also, in order to have comparable data, this data need to be obtained with relatively comparable trawling operations. So basically, the trawling vessel should have a speed of 3 knots during performing its howl. Also, information regarding the vessel, speed, the howling depth, the geographical position should be continuously monitoring, and the entire howl duration should correspond to 30 minutes of trawling. And in this figure, you can actually see how the start at end of the trawling operation is defined. So once the howl is being inserted into the water, this is the moment that is considered as the starting point of the trawling operation, and the moment that this is being pulled up, this is defined as the end of the trawling operation, and this should correspond to a 30 minutes of duration. And here you can see typically what is being caught in the howls, and plastic bottles, fishing nets, and again, the same litter items classification list should be deployed. And here, the trickiest point, of course, is to express results per sampling unit, because it's quite difficult to calculate the swept area by the howl. So this is why you see many research papers reporting results as litter items per howl. But in order to be able to compare these results with the results that are being obtained with the use of the help of divers, the results should be expressed per square kilometer. And here you can actually see that in order to do this calculation, we need to know the velocity of the trawling boat, we need to know the opening of the head rope of the howl, we need to know the time that has been spent in trawling. And then for the Mediterranean, an X factor is being used in order to compute the path that has been swept by the trawl. And regarding materials and equipment, again, they are very similar to the materials that are being used for all other macrolitter surveys. So all this information can be found in an e-learning module that we have developed within the Plastic Busters initiative, and I have shared with you 2 documents. And one of these is, in fact, listing this e-learning module as well as other key resources, including these protocols that were featured here today with this presentation. And unfortunately, we don't have time to go into results, but if you want to have a look at the kind of results that are obtained by this kind of monitoring activities, you can check out some of my published works here. So with that, I would like to thank you all for your attention. And I would like to see, before we pass to the next presentation, to see whether there are any questions in the chat. So just a second. All right. Okay. So let's see. Good morning. All right. Is there any question that someone would like to ask regarding this featured methodologies?
Yes. Hello.
Hi. Ideally, in order to avoid the connection issues, can you please post the questions in the chat in order to facilitate the, because we're on a very limited time. So kindly post the questions on the chat and we will respond to this, okay? If that's possible. And I will start with the first one that I see here. What about monitoring using robots? And indeed, for example, for the seafloor, ROVs are used, but we are not yet there in order to be talking about a harmonized approach with the use of robots, because obviously there are some difficulties even with the use of ROVs on computing either the sampling unit and having a certain harmonized approach when it comes to that, but also difficulties in the classification of the litter items, because these the ROVs obtain images, and of course it's not so easy sometimes depending on the observation conditions and the conditions that the images were taken to classify this. But this is an area where a lot of researchers are working. For sea bottom, but also for sea surface. Yes, in fact, there are not exactly robots, but having cameras placed on ships in order to constantly take images. And there are efforts to sort of harmonize and increase the quality of the images that are being taken, and also increase the precision of the identification of these images. But so far at European regional seas, when we talk about monitoring, not research, we are not referring to the use of robots yet. I assume that this will be one of the future developments. I don't know if Cristina would like to say something also on that regarding the use of robots in monitoring. We cannot hear you.
Okay, sorry for this. And maybe I think the Cristina Panti that will give the future presentation. She has some experience in the application of this technology. And I suggest maybe at the end of the presentation of Cristina, add some new data concerning the application of this technique, especially in marine protected areas. Thank you.
Great, thank you, Cristina. Anyway, I don't see any other question. Okay, I see also with the use of acoustic. Yes, there are approaches still at I won't say infancy, but they're currently under development and not yet deployed for monitoring purposes. Monitoring in order to support the policy and decision making. So yes, the answer is yes. And as I said, there will be a lot of emphasis placed on that in the near future. So unless there are any other questions regarding macrolitter monitoring, I think that it is a good time to welcome with us Cristina Panti, that will be presenting the monitoring approaches for microlitter in the different marine matrices. So Cristina, lovely to have you with us today, and I pass the floor to you.
Okay, good morning, everyone. I'm very pleased to be here and talk with you and sharing our experience on microlitter. And please mute all the microphones. Thank you very much. And as already Tommy said, I will present some insights on the approach or monitoring approach for macrolitter on coastal and marine environment. I wish you can hear me well and you can see my screen. So just put here this. So As we already said, I will talk about microlitter, so the smallest part of litter that we can monitor on beach sediments and on sea surface. Just to remind you, also if Tommy already talked about definitions, microlitter is primarily composed by microplastics, and microplastics are plastic particles that have the longest dimension under 5 millimeters. They are also divided into large microplastics from 1 to 5 millimeters and small microplastics from, with the dimension smaller than 1 millimeters. Another definition that we should bear in mind is that microplastics can be defined as primary or secondary. Primary if they are directly releasing to the environment as small particles, as for instance, pellets or microbits, or secondary microplastics, then originate from the breakdown of large plastic items, and they fragment into smaller pieces of plastics with different shapes, colors, and types. So, bearing these definitions in mind, we can perform the monitoring of microplastics both on beach sediments and floating on the seafloor. Regarding the site selection, already Tommy extensively explained the criteria that we should address when we are doing beach sediment monitoring for microlitter, so are almost the same as the ones that Tommy already told you regarding the choice of the sites. And one of the most important things is that we should select sandy beaches or with very small pebbles. Then, in addition, the location of the survey should be partially stratified, and again, the site selection should be related according to the different pressures, different anthropogenic pressure, and the different exposure to litter. So, as we already say, before, according to the position of the beach, if the beach is inside the marine protected areas, in the close vicinity of a port, is an urban beach, and so on. And we should also record the urbanization level of the beach. As for the other surveys, it's very important to perform seasonal survey, optimally in winter, spring, summer, autumn, in the month of January, April, July, and October, in order to have a clear picture over the entire year, also because the accumulation of macro and microlitter depends on currents, season, the amount of rain, and so on. So, monitoring the microlitter on beach sediments, the sampling unit is the same as the one for macrolitter, but we will see the small difference that we should take into account. So, the transit is defined in 100 meters, or if the beach is more than 100 meters, and we should identify the tide line and the upper level of the beach, as already Tommy said, that can be defined by the presence of the vegetations, dunes, fences, roads, and so on. So how do we choose the plots for each transit to be monitored? Ideally, we should choose 9 plots of 1 for 1 meter dimension, but we can also scale down the dimension of the plots that should be located at the beginning of the transit, in the middle of the transit, and the end of the transit. But one of the most important things is to identify the low tide accumulation area, the high tide accumulation area, and also the off accumulation area. You will notice when you are on the beach that there are some lines that define the accumulation areas and the off accumulation areas, and we should perform as much as plots as possible to have a more representative sampling. So we should sample inside these plots. Then I will show you in 1 second how we can collect the sand. We should sample the top 5 centimeters of sand, weight and sieve. It's very important also to record the GPS coordinates for each plot in order to then to have the geographical distribution of the litter. So we, as we said, optimum 9 plots are to perform 9 plots is the optimum, but we can perform also a minimum of 3 samples along the 3 transit, and the sampling unit that can be defined by the simple square, as you can see here in the picture, made of wood or with plastic tubes. The sampling unit could be 30 for 30 centimeters, for 50 for 50, or 1 meter for 1 meter. And we can collect the sediments with the metal shovel, as you can see here in the pictures, and then weight and sieve the sediment. So once you have collected the amount of sand that you need, you should sieve on a 5 millimeter and 1 millimeter mesh size sieves. As you can see on the top, you have the 5 millimeter sieve. In the down sieve is 1 millimeter. In order to reduce the sample volume and not to carry in the lab the sands. And during the sieving, you can remove the non-plastic items, for instance, small pieces of wood that will interfere then with the subsequent analysis, and collect in paper bags, Ziploc bags, or other containers as glass jars the samples. Then you will bring the samples to the lab and you will perform the subsequent analysis. Here is the sampling sheets, the survey sheets. So it's very important to write down the location of the beach, the sampling date, the characteristics of the beach, and to locate here in this kind of scheme the number of transit and the plots that you performed, and the location of and the coordinates of each plots. When you are in the lab, one of the approach is to sieving the samples, so with the sieve with the 5 and 1 millimeter, and perform the analysis under a stereo microscope. But to facilitate your analysis, you can also let the particles to put the samples in a density flotation solution that you can also perform simply with sodium chloride, with the saturated solution with sodium chloride. And according to the different density of the plastic polymers, they will float on the container where you perform the analysis, and then the sand and the organic matter will sink to the bottom. There are several salts that you can use, some salts that are more dense than other, so that you can have a better gravimetric stratification, but you can also use sodium chloride that is the most convenient, the most easy to find. But bear in mind that when we are talking about macrolitter, in particular microplastics, the contamination that we can put inside the samples is very high. So also in the all steps that you perform in the lab, it's strictly recommended to using lab coats in order to not include additional plastic items, because you know that also fibers, for instance, from textiles can be considered as microplastics. So we need to be very careful and do not introduce additional contamination in our samples. So, for instance, fibers coming from our clothes, but also airborne contamination. Once you have isolated your plastic items, you can put them in a petri dish and observe by naked eye and under the microscope, the stereomicroscope, for the smallest particles. And then you have to classify the particles according to the type. So following these categories as pellet, fragments, fiber, film, filaments, microbeads, and foam. These are the categories that have been developed within the MSPD task group. And so you can see here in the slide some examples of the different categories. So fragments are particles that differs from films for the thickness. For instance, styrofoam particles you derive from styrofoam, so it's quite easy to distinguish. Filaments, for instance, are like in this, are very long but with a thin diameter, and then there are pellets that are usually primary pellets that are used to produce larger plastic items. Then you can classify the microplastic according to colors. Usually they are used black, blue, white, transparent, red, green, and multicolor. And then since the colors have a wide range of glances and different colors can be interpreted by different people with light blue, dark blue, for instance, then the different colors can be also grouped in other. And in the end, one of the most important analysis, but it's not easily, not always feasible for all the researchers, but also for all the people that are interested in this kind of monitoring, is the polymer type identification that can be performed with a FTR spectrophotometer. There are some that are also very easy to use, or with the Raman spectroscopy, but these require advanced skills in the plastic polymers analysis. In this case, you can identify the polymer and understand if they are made of polyethylene, polypropylene, and so on. So it's also important for instance, to attribute sources to these microplastics. Regarding the reporting units, so their reporting units is very important to allow the proper comparison among different surveys. So the most accepted reporting units are the number of microplastics per area when you calculate your area in square meters. The microplastic per volume, the microplastic per mass, because you need to weight the dry sediment that you collect, and the mass of microplastic per area. So you need to report the number of microplastics per area and in terms of numbers and in terms of mass. Finally, the materials and equipment that you need. So it's quite the same as the material that we already said in the Thomais presentation. One difference is represented by the plot that you need to obtain to carry with you to select the number, the area to be surveyed and the sieves. Then stereo microscope, and this in this last slide, as an example, I just put a example of FTIR, but there are a wide array of instruments. So I hope this is clear. Then I pass to the sea surface monitoring, and then I let you, I leave you the time for questions. Then again, given to the distribution, the very heterogeneous distribution of floating macro and microlitter, the criteria for the service selection are very dependent on the scope of your research and or of your monitoring. You know that floating macro and microlitter varies across because of currents, of ocean currents, because of winds, because of the vicinity to the sources of anthropogenic litter, and also because they vary on the oceanographic features of the site that you are surveying. So the selection is very crucial for the proper monitoring of floating macro and microlitter. So if you are more interested in coastal environment rather than pelagic environment, you will define different transits in different areas. But another approach could also be the random selection of the survey sites in your study area. As for the other surveys, at least 2 surveys in 2 seasons should be performed. So the proposed surveys are in autumn from mid-September to mid-October, and spring from March to April. Here you can see an example of macrolitter water surface data sheets. So that is quite similar to the one that Thomais shows for the macrolitter. So it's very important to write down the location idea, the country, and the date that where you are carrying out your service. And one very important that is very crucial is to write down the coordinates of the start and the end of your survey, the coordinate system, the vessel speed, and the time of the start and end of your survey. Another very important data to be noted are the environmental parameters. So the wind speed, the wind direction, and the viewing quality, and the sea state. This is very important because, as already Thomais said, we should perform the surveys only in calm sea, so with the sea state between 0 and 2 of the Beaufort scale, in order to not affect the sampling because of the wind and the currents that can affect the reliability of your surveys. And then you can also note all the other site characteristics that will help you in the data analysis. So I will show you a video on the manta troll survey that we perform. So the manta net, as you can see in the video and the picture, is a net with these two wings that let them the net floating and sampling only the surface layer of the water. The mouth opening is could be from of 60 centimeters, but there are several models of the manta, and the mesh size of the net should be 330 microns. Usually the transit is carried out for 30 minutes with the speed of the boat between 1.5 and 2.5 knots. As I was saying before, the low wind conditions, the sampling should be performed in low wind condition with the scale of Beaufort scale from 0 to 2. And it's very important once the manta net is at sea to take the coordinates, the exact GPS coordinates then that will be useful for the determine the area that you surveyed. Then once the manta is retrieved on board, then you have to rinse from the external the net, then collect all the material that is in the cod end, and then after collecting the material to sieve on 5mm sieve if you have, in 0.3 millimeter sieve if you have also the 5 and 0.3, you can use both of them to have a first dimension separation of the samples. Then you can collect the sample and you can also collect some organisms if you are interested in doing organism analysis collected in the same area with the manta troll. And then you can collect the samples and store for further analysis in low temperature, but the usual container are, for instance, glass jars that where you collect your sample with some ethanol. So here there are just a few shots on the fundamental steps. So the net at sea, the collection of the net, the collection of the cod end. When then you have to rinse very well the cod end, collect all the samples in a container, a beaker or something similar, and filtrate the samples on sieves and collect them in seawater and ethanol in glass jars. When you arrive in the lab, the sample should be performed in a few days after the collection, but if you can't, please be sure that you add ethanol to preserve the samples in order to avoid that the sample will degrade, and you can store the samples at 4 degrees in a normal fridge, so the degradation of the organic matter is slowed. Then in the lab you should sieve again the samples with 3 sides of the sieves, 5 millimeters, 1 millimeter, 300 microns. And then counting and sorting the microplastics under the stereo microscope, as we have seen for the microlitter in the beach. Remove all natural debris and then the samples can also be dried and then weighted, and then perform in the end the FTIR spectroscopy for the polymer identification. Usually you can report the, you will find mesolitter, so particles that are between 5 and 25 millimeters, and then microlitter that, as we see at the beginning of the presentation, can be divided in large and small microlitter. In this case, normally you shouldn't find plastics, microplastics smaller than 300 microns because the net is 300 microns. So all the particles that are smaller than 300 microns should not be collected unless they get entrapped in the organic matter. Again, for the sample processing and size classification, the size classification and the type and colors are the same as we saw for the macrolitter on the beaches, so type, colors, and polymer type. Regarding the reporting units, the microlitter can be reported as number for square kilometer or number for square meters, and you will calculate the area of the survey, calculating the area by the net, the opening of the manta net. So if, for instance, if you have 60 centimeter of the manta net, you should calculate the area of with the rectangular, for instance, with the smallest dimension of 60 centimeters, and then for the length of the transit that you can calculate with the GPS coordinate, and then normalize your data to the square meters or square kilometers. Another option is instead to calculate the volume that you filtered, because for each survey you will filter and you will survey a different volume of water that can be calculated according using a flow meter that could be placed inside the net, and then calculate the cubic meter or cubic kilometer. Additionally, you can report also the microlitter per mass, normalizing the data to the area or to the volume. So here you can see an example of a petri dish with isolated microplastics coming from a manta net sample. Regarding the sampling equipment, you need more specific equipment. On the top of them, the manta net with the wings and mesh size of 330 micrometers, the flow meter. One important, very important object is the GPS, that you can also retrieve the coordinates from the GPS of the boat, if the boat has. Glass charts, several other equipment material, but also sieve are very important, tweezers, metal spoon to collect all the samples from the sieves, and ethanol to preserve the samples, and the waterproof markers, of course, to label of the samples. When you are in the lab, then you need a stereo microscope. You need tweezers and micro tweezers. These are very important to select the particles. Remember the cotton lab coat, glass petri dishes, ethanol, sieves, and all the other laboratory stuff and bench equipment for the analysis of microplastics. So You can find more details on these two resources. So these are the documents that collect all the type of monitoring and analysis that we are presenting today in this training. And I thank you very much for your attention, and I open to ask to your questions.
Thank you very, very much, Cristina, for this very detailed and comprehensive presentation. It was really enjoyable, in particular, this add-ons with the videos. I think it makes things much more clear. I think that there were a couple of questions for you in the chat. Let me go through them quickly. First of all, there was one participant that mentioned that it would be better to use an SMI unit for the separation of microparticles at under density separation in glasses to avoid airborne contamination. And he specified that this SMI unit, sediment microplastic isolation, is a custom-built apparatus which consistently extracted microplastics from sediments in a single step with a mean efficiency of 95.8%. So I don't know if you would like to add something to this comment.
Could be an option, but I think that not all people can have the sediment microplastic isolation. So using the salt is an easy way to perform the analysis. Another way is also don't do the separate the gravimetric separation, but just sort visually the particles. So there are several approaches depending on your needs and depending also the possibility that you have and the lab equipment that you have.
And perhaps maybe I can add to what Cristina is saying, because here the featured approach, obviously there are many different variations of the protocols that we are presenting here today, but we are presenting the ones that have been adopted by member states of the European Union and by contracting parties to the Barcelona Convention to implement for monitoring purposes. So monitoring in general has to be cheap, has to be robust, has to be accessible to different kinds of actors with different kinds of settings. So this is why, even though in some cases there might be more comprehensive ways in order, for example, to separate microplastics or in order to do other things like deploying robots, satellites, drones, and more exquisite and sophisticated means. Here we are focusing on those approaches that are relatively low cost and they have been deployed by the countries for the purpose of monitoring. So going now to another question or a comment, which refers to that following. Using sieve on the beach during the process to have perfect results does not affect the habitat of organisms that live in the beach. Does it have a negative impact on marine environment? If it does, what other options are there to collect microplastics? An interesting question, I think.
Yes, and then help me to reply, Tommy. Now, so I think there are any other option, because you cannot go on the beach and try to collect one microparticles at a time, so it will last forever. And regarding the organism, usually if you go in the area of the sandy beach, it's very difficult to find organism, as far as my experience. While we are collecting and we are sieving the sieves, the sand, sorry. Maybe if you are referring to the organisms that live inside the sand, we collect only the top 3-5 centimeters, so it's not so easy to collect organisms. And then regarding some areas that are very protected, for instance, for seabirds, you do not perform the collection of plastics and microplastics during the nesting season, for instance. So I think that our participant is referring to smaller organisms, but as far as my experience, it's very difficult to find organisms when we are receiving the sands.
Yeah, I tend to agree with you, Cristina. And in addition to that, the amount of sand that is being sieved is really so small.
Yeah.
So then we have another interesting question by our dear friend and colleague Hamdi, that he asks, what is the most common, or what are the most common microplastics in the Mediterranean, and what is the largest source of microplastics?
Okay, so also in this case, I ask for the help from all of you, of the Cristina and that, but as for the other seas and oceans, most of the microplastics that we find are fragments, so deriving from the breakdown on larger items, mainly made of polyethylene. That is the most common used plastic polymers for several applications, mostly for packaging, and polypropylene. And these are the most common. And fragments, films, and filaments are the most found. As far as our experience, is more difficult to find for instance, primary pellets floating at the sea surface, but it's more common to find primary pellets stranded on the beaches, for instance. So also depending on the environmental matrix that you are analyzing. I don't know if any want to add.
I think that you answered wonderfully. And if I may say also, similarly, not just for microplastics, but for macroplastics, the same thing, that what the kind of the types of macro or microplastics that you find is closely linked to the kind of pressures that are exerted in the sampling location. So obviously, if you are in an area that is mostly impacted, I don't know, by industry that is using virgin pellets to produce plastics, maybe you will find these pellets as the main source of microplastics. But in general, the majority in all locations is what Cristina highlighted, fragments of macroplastics, the amount of macroplastics that is out there, exposed. And actually, we will be touching upon this in the measures-related webinar. And the mechanisms of degradation of these macroplastics into smaller bits and parts. I think that the answer is relatively easy to give, that fragmented macroplastics are the most common microplastics found, and then, as Cristina said, from packaging. So now I see another question. This had already popped up before. How can individuals help clean up polluted beaches from oil stains resulting from ship waste? We will not respond to this simply because this webinar is dealing with plastic waste, and we are not touching upon the topic of oil spill, which is a topic on its own. So we apologize for that. Then, this is a question for you, Cristina. If we don't have a manta net, is it correct if we use just bottle for sampling water? And what exactly is the SHMP 1.3 grams per cubic centimeter?
Okay, actually collecting the water with the bottle is another kind of technique to collect water, but you are not collecting exactly the same particles that you will collect with the manta. And then, just for an example, when you collect the sea surface for, I would say, 20 minutes in 2 nodes, you will filter more than 700 liters of water. So you have a quite representative part of, not representative if you compare to the entire surface of the world, oceans and seas, but you collect a quite large amount of water, and with bottle you can collect 1 liter, 2 liter, 5 liters, but you are not collecting the sea surface, for instance, because, and this is another topic regarding which is you should understand which is the end of the scope of your research. If you're collecting the sea surface, you need a tool that will collect the sea surface. If you are collecting the sea column, then the water column, then you can use bottles. You can use bottles that reach different depth, but if you don't have any alternatives, you can use bottles and baskets, but it's quite a different sampling approaches. Also for the dimension of particles that you are collecting. Maybe with the bottles, you will collect smaller particles than 300 microns. They are not collected with the manta. And regarding the SHMP, is a salt, is a sodium hexametaphosphate. It's just a salt that has been used, that has a high density. So you see 1.3 gram per cubic centimeter, and then can help to, in the gravity sedimentation, to collect all the heavier particles to be carried in the bottom of the container where you perform the gravimetric isolation of particles, and let the lighter particles to float. So it's just an option to other salts that have a lower density.
Thank you, Cristina. Then we got another question regarding, so in some areas there are wrecks at the bottom of the sea, and then this wrecks may release some fragments, and the question is whether that impacts the study or the sampling unit selected. I assume this is for the floating microlitter sample.
I think so. Yes, can be, but this is, I think, then you choose the site in the site selection phase. You should take into account all these, also these kind of potential sources, and then analyze the data according to the info that you have.
Great. Let's move on to the next question, because we have an overflow of questions for you. So the question is, how can we identify the microplastic less than 1 millimeter with the spectroscopy infrared?
You need to transfer the particles under the spectrophotometer and then analyze them. And it's smallest are the particles, more difficult is the transfer, but you can, and you can help. You should look at the particles under the stereo microscope, have the FTIR very close, and then put the particles under the FTIR. So it's not very easy, but it's feasible. You just need to experience it a little bit. I don't know if I replied as you wish, but
I think it was just fine. And then another question: why do we have to use ethanol for microplastics conservation, for maintaining, for storing?
Yes. The problem is the degradation of the organic matter that then can sink and produce very bad smells. So if you put ethanol, you add a preservative that is not toxic, because at the beginning of the story, years and years ago, we used, for instance, formaldehyde to maintain the zooplankton and phytoplankton intact, but then it is toxic. So ethanol is a kind of compromise to store to let the organic matter to not degrade too much, and then to perform the analysis in good conditions.
Okay, then another question is related to when we take things out of the water, like water bottle or any small plastic cups or whatever, and there are fish eggs in, I think we should keep them in the water. I'm not quite sure now. I think that this question is related to the seafloor litter, macrolitter monitoring, if I understand correctly and I read it correctly. When we take things out of the water, like water bottle or small plastic cups, okay, that there might be inhabited by some marine organisms. Is that the question? Because obviously when we take them out of water, we try to empty the content. Okay, but also we need to all of us understand that these activities are not taking place in areas, or all precautions are considered in order to avoid affecting, impacting biodiversity, but inevitably some small organisms will be sampled. It is inevitable, and this is something that is occurring in all sorts of researches. So we do the maximum that we can to avoid having any kind of impact, but inevitably some organisms, very small organisms, will be sampled. We cannot do something about that.
Yes.
So then
you can try to preserve as much as possible the species that you accidentally collect, for instance, fish larvae or isopods or whatever you collect, but it's not possible, as you do in scientific monitoring program. You should sacrifice a little bit of species to obtain your objectives.
And then we have two more comments, last questions, and I think that we can wrap up this session. The one is actually, is there a possibility to create a joint initiative to be circulated in countries bordering the Mediterranean aimed at educating children and providing practical training in collecting ways to preserve their society and the planet in general with support and funding from the European Union? Maybe I should be responding to this in the sense that a lot of related initiatives have been implemented in the Mediterranean. Unfortunately, of course, as every kind of project, they have a starting point and an ending point, and then all of us are striving for continuous funding. But I'm aware that there will be, through a project that is also contributing to this webinar that is entitled WES, there will be an initiative for plastics, and there will be champions that will be sort of awarded for their efforts to either educate children or other types of initiatives. So there is a lot going on. Maybe I can, in the next webinar, present you just a mosaic of the different initiatives on this particular topic that is that are taking place in the Mediterranean as we speak. And then the last question was, it was comment, I think, basically for my set of presentations. It was about that the solution to the problem is starting with cleaning up rivers and streams. And actually what we will be discussing in the next webinar is the concept of cleanup operations and to which extent this is an optimum approach for dealing with the problem of marine litter. What is the added value of cleanup operations? And the emphasis, of course, of our approach as Plastic Busters is that prevention is it's key. Obviously, we need to clean up waste hotspots, marine litter hotspots, but we will come back to that in today's time. I think that this was all. And
thank
now,
you all the people for the attention.
Yes, a lot of attention, Cristina. Bravo, well done. And now I will give the floor to Matteo, who will be presenting monitoring approaches for marine litter on biota. So, Matteo, the floor is yours.
Hi, good morning to everyone. I'm going to share my screen. Okay. Okay, can you see the screen? Okay, so thank you for inviting me, Tommy, to speak about the monitoring approach to assess the presence of marine litter and biota. I will make a brief introduction on the issue, and then I move to show you the approaches for the large marine vertebrates. So briefly, the ingestion and the relative transport of chemicals is one of the most noxious effects on marine wildlife regarding the impact of marine litter, and especially worldwide is recorded that a lot of species have ingested the marine debris. Marine litter can be ingested intentionally, so during the foraging activity, due to the color of the plastic items or the age stage of the animals, or accidentally, if the animals are not so selective in the feeding activities, such as the filter feeders, or through the secondary ingestion, if the animals feed on the prey that have already plastic on their gastrointestinal tract. The ingestion may lead to the mortality of organisms, but can also have some sub-lethal physical and chemical effect. Worldwide, there was an increase of the species that are impacted by marine litter. In particular, regarding the sea turtle, all of the 7 species of the sea turtle worldwide are to be demonstrated to be impacted by marine litter, and more than 50% of the marine mammal and more than 40% of the seabirds. In the Med, the ingestion of marine litter has been reported since the late 80s, but they are only related to the feeding ecology studies and no specific studies. Only recently specific studies have been carried out on and beside a lot of amount of scientific paper, there is a lack of information, and the real impact of marine litter on biota remain underestimated. This may be due to the lack of the standardized method and protocol, since the only information that we can obtain to the whole data set of the published paper is related only to the percentage of the affected samples or affected specimens of ingested litter. This is why we need normalization methods, an harmonized method to properly evaluate not only the amount of litter, not only the percentage, but also the amount, and as Cristina will explain later on, the effect on the health of the species. This is required by the European and United States, both in the Marine Strategy Framework Directive and by UNEP action plan of the Barcelona Convention. Okay, as Tommy said before, there was a discussion about the protocol, and we adopted in the Plastic Buster MPA. We collect all the information and all the data required by different monitoring program to develop a specific common sampling protocol and classification protocol. Okay, first of all, we have to differentiate based on the size of the litter. Usually in large marine vertebrates, that are the species that I'm going to show you, we investigate litter with more than larger than 1 millimeter. On the other hand, in fish and invertebrates, usually we focus on, and that we will explain how, on the litter between 5 millimeter to 100 microns. Okay, so large marine vertebrates, who are those beautiful animals? Okay, mainly we focus the attention on sea turtles. In the med, we have all the 3 species, but the most common is the loggerhead sea turtle, caretta caretta, the seabirds, and the cetacean. So we usually are able to detect the presence of marine litter in those species only in the stranded organisms, and most of that are protected species, so we need to be in contact or be part of a network with a specific permit to handle this animal. But if you are one of these network and we want to study the presence of litter, we can start with collect the information regarding the contact, the site of the stranding, and the identification of the species. Obviously, the identification of the species is crucial to properly summarize the data at the end and compare the data with the other place. Okay, then is important to take the specific biometric measurement. For example, the CCL for the sea turtle, or the bill length, or the weight of the seabirds, and the total length of the cetacean. The length should be taken with a precision on 0.01 centimeter, and the weight, if it's possible, obviously for the sea turtle and seabird it's easier, while for a small cetacean and especially large cetacean is more difficult, but we can collect the information at least at 0.1 kilograms. Then we have to note the conservation status and the body condition of the organism. Obviously, for the sea turtle, we can also, and for seabirds, we can also have the level 1 alive animal, especially in the recovery center. But usually it's more common to find the level 2 fresh, recently fresh organism, or level 3 organism in good condition, but in which the decomposition is already started. And in level 1, 2, or 3, it's still possible to perform the analysis of the gastrointestinal tract to identify the ingested litter, and also other analysis, and Cristina will explain you which kind of analysis. If we found the animal at level 4, it's still possible in some case to collect the gastrointestinal tract. But if they are more like to be mummified, it's not possible. So usually we focus the attention and the analysis on the level 1, 2, and 3. Okay, then we have to collect the entire gastrointestinal tract, And I said before, if you are not allowed to handle the protected species, you need a specific permit to do that, or require the vet help. You have to isolate the three portions of the gastrointestinal tract: esophagus, stomach, and intestine. You can use the 2 clamps, 2 or 3 clamps, or a rope, natural rope, to separate those 3 sections. And this is the need in order to identify the amount of litter for each section. So we need to properly separate all the 3 sections, and then analyze the content and separate the result for all the 3 sections. Okay, once isolate, the gastrointestinal tract should be opened with the schist or Oscar, and all the material should be collected, and rinse should be collected. Then, if we want to stop at 1 millimeter, as usually required by the Barcelona Convention and Marine Strategy Fairmont Directive, you can do the visual sorting and use a 1 millimeter sieve. Or if you want to go in, look for the smaller microplastic, less than 1 millimeter, you can add an additional sieve of 100 microns for the small microplastic analysis. Then, using a microscope or by naked eye, you have to sorted to count, weight, and sorted the different plastic, the different litter items. It's essential in this phase also to collect the natural food and natural non-food remain in order to properly evaluate the percentage of food or natural items in relation to the anthropogenic material. For the litter categories only, we need the number of each item for each categories. There are 5, should be industrial plastic, industrial sheet-like, industrial thread-like, foam, fragments, and other plastic. But, as I said, Tommy, before, if you are able to detect it, to correctly identify the plastics, better to use also put the joint list code for the litter items, in order to properly evaluate the source of the plastic items. Then, if you have a FTIR or a Raman spectroscopy, you can analyze that to better evaluate the source of the plastic items. At the end, the reporting, the collection of the data, you have to evaluate the frequency of occurrence of the ingested macro and microlitter for each species. You have to calculate as the percentage of the individual with plastic and individual without plastic within the area, the abundance of litter, and so the number of ingested items for each individual, calculate as a total items for each for each categories, and the total dry weight of the material expressed at the grams for individuals. And thanks. I pass the floor to Dario, who he will show you the smaller part and the invertebrate and fish analysis.
Thank you, Matteo. And meanwhile, all the participants can be thinking of the kind of questions that they would like to ask you in the chat. Okay, Dario, the floor is yours.
Okay. Okay, can you see my screen? Okay, good morning to all. And first of all, thank you very much for this opportunity. And Now I'm going to talk about the second part of the monitoring approach for the assessing of presence of marine litter in biota, in particular in fish and invertebrate species. How Matteo says, the ingestion of marine litter in Mediterranean Sea has been reported since 1988, and more than 138 species with records with marine plastic ingestion in gastrointestinal tract. And in particular, more than 60 papers reported microplastic ingestion, and fish and invertebrate species represent more than 80% of the total investigated species, we can see in the graph. So my colleague Matteo presented you the monitoring method concerning the meso and macro plastic in megafauna. And now I'm going to tell you about the methodologies required to investigate the impact of microplastic from 5 millimeters to 100 micron in fish and vertebrate species, how a marine strategy framework directive guideline suggests that the content of fish gastrointestinal tract may be analyzed to determine the microplastic ingestion. So from our research group, we made an assessment by bibliographic research on the microplastic ingestion in the fish species from our Mediterranean Sea. And here we can see a table that summarizes the most studied species from the Mediterranean Sea and the relative percentage of plastic ingestion. In particular, we selected the species with more than 114 individuals analyzed from at least 4 different studies. And we can see how the average occurrence of microplastic is 32%, and the bog, the boops species, is the most studied species and revealed the highest occurrence. It is more than the 50% of the individuals have ingested microplastic. So here we can see the selection criteria for the selection of sentinel species. Then we can start from the background information of the animal. So clear taxonomic identification and scientific knowledge on the ecology and biology characteristic of the species. Then we move to the specific habitat information, so the habitat and the home range of each species, and the trophic information and feeding behavior of the animal. So the opportunism feeding, filter feeding mode on predator, pelagic predator, and the different trophic level of the animal. So moving to the spatial distribution of the animal. So we have a large or medium or small home range of the different animal, and the commercial importance and the conservation status of the species. So the commercial importance for the human health, if a species is protected, threatened, or managed species. And finally, the documented ingestion of marine litter from studies from the bibliographic research. So the first point for monitoring and sampling strategy is the sampling approach, the sampling frequency and timing, and the sampling size of the animal. So the monitoring strategy for the invertebrates, we start for the sampling approach, and we sampled, for example, 2 species such as fertile feeder invertebrates such as mussel, and other invertebrate species such as sea urchins. And these species should be collected following these modalities. They were collected from the study area, purchased by local fishermen or scuba divers active in the study area, or we can collect in adjacent areas with similar condition with our study area, and following reallocated in the study area with the use of metal cage. And then after a period of 3 or 4 weeks, they can be sampled. Concerning the fish species, the sampling approach should be followed with the same approach purchased by local fishermen in the study area, or collected by researchers within dedicated scientific campaign. Concerning the frequency and timing of the monitoring strategy, for fish and invertebrate species, a minimum of 30 individuals should be collected. And for fish species in particular, the animals should be sampled at each side from each environmental compartment, for example, benthic species, demersal species, and pelagic species. From particular animals, such as the endangered species, for example, the manta ray, we can sample where occasionally found stranded and can be analyzed in very small number. Here you can see an example of monitoring sample sheet for fish and invertebrate species that we use for our sampling. And in this sheet, we can record the name, obviously, of the species. We have all the biometric data of the animals, so the weight of the whole fish, the measure of the total length and length for fish species. And then we have to weight the gastrointestinal tract of the animal and record the gender, the maturity stage, and so on. Here I summarize the essential step of the procedure, of the monitoring procedure. So we're starting from the sampling data and the sampling approach that I showed now. Then we move to the dissection and tissue collection of the animal, followed by a tissue digestion of the gastrointestinal tract. Then we have the filtration of our sample and the microscopy analysis and microplastic isolation, and finally the polymer identification. Here we can see the first step of the dissection and tissue collection of the animal. On the left, we have the muscle sample, the invertebrates, that we use all organisms for plastic detection and also for plastic tracer detection of contaminants. And we can see a Mollusc barbatus, a fish sample, where we take these three tissues for our analysis. In particular, for plastic detection, we use only all gastrointestinal tract from the esophagus to the intestine. And then we take also the muscle for additional analysis on plastic traces and the liver. I show a little video of the dissection. This is in front of the animal, is the liver. And we take the gastrointestinal tract for the tissue digestion, and the muscle is there from the other analysis. So I move to the second step, that is the tissue digestion of the gastrointestinal tract. We place the whole gastrointestinal tract in a glass beaker or tube. Then we weight the gastrointestinal tract and rinse with purified water to avoid the airborne contamination. We place in a petri dish a filter paper for a blank contamination of the working area. And finally, the last step is the digestion with the potassium hydroxide, KOH, at 10%. We use this ratio 1:5, 1 weight of the sample and 5 volume of the KOH. And we incubate at 50 degrees overnight in the thermostatic bath. There is the result of a detailed intercalibration comparison that we made, and we published a paper in the harmonization exercise in the plastic bustler MPH project. And so we move to the sample filtration. We have our sample, and we pass the sample through a metal sieves of 300 micron above a filtering apparatus. And finally, with a vacuum pump and a fiberglass filter of or 1.2 or 1.6 micron of porosity. The metal sieve should be covered with aluminum foil, and filter must be placed in aluminum foil covered petri dish and dried at room temperature. All filtering procedures took place inside a laminar flow cabinet. And this is a crucial step. It's very important to use a procedural blank to test the airborne and ambient contamination. And for this, we can use a similar volume of KOH at 10% in a beaker without sample, and follow the protocol that I described now. Finally, we move to the sample isolation and characterization of the isolation in microplastic particles. So after the digestion procedure, we check the filter to isolate plastic items with a stereo microscope. Then we photograph, count, and record the maximum length of plastic particles using a imaging software. And then we have to categorize our plastic items according to shape, size, and color. In particular, in this slide, you can see the various categories of shape that we usually found in the gastrointestinal tract. We found the fragments, so the irregular shape and hard particles, the film that are tiny and flexible plastics such as plastic bags, food wrappers, or tape, foam particles such as a near spherical or granular particle with easily deform under pressure, the filaments, so a flat flexible particle with a smooth or angular edge, and the microfiber, that is a synthetic fibers that having a diameter of less than 10 microns. The last step of our protocol is the polymer characterization of the microplastic. So we analyze at least 10% of the detected microplastic by FTR to determine the polymer composition and confirm the polymer origin of our detected particles. I show you an example of polyethylene spectra that we found in these white fragment particles. And so the final steps is the collection of the data. So our result for each species, we made an assessment for the very important data, the frequency of occurrence. So the frequency of occurrence of ingested microplastic for each species is calculated as the percentage of individual examined with ingested microplastic. And the other very important data is the abundance of the microplastic ingested per individual. So the average number of items per each individual analyzed for each species. Currently, there is some inconsistency in the literature in reporting abundance, because it's recommended to report the average number of items per individual, both considering all individual examined and only individual found with ingested particles. So it's all, and thank you very much for the attention.
Thank you very much, Dario, for this very interesting presentation. I do understand that monitoring biota is marine litter in biota is more sophisticated approach technically wise. So I understand that the fact that we don't have so many questions popping up, but is there something that someone would like to ask, even if it's a clarification? Now that we have Dario and Matteo with us, they could respond to all of your questions or doubts, concerns about this kind of monitoring methodology. No? Anyway, we have time. It seems that we are doing well with time management, which is exceptional for our group. So now I would like to pass the floor to Cristina, who will present the very exciting, let's say, aspects of marine litter monitoring and how marine litter potentially affects the health of biota. So Cristina, the floor is yours.
Yes, thank you very much, Tommy, and First of all, I would like to say that is a kind of my miracles, because normally we take a lot of time for our presentation, and today we respect totally the time scale. So I think it's very, very positive. Then probably you can leave more time even at the end of the training for the discussion with our friends in order to incorporate all this group of information. And I try to share my screen. Did you see my screen?
Yes,
Perfect.
we do.
Yes. And as I say from Tommy, I have a quite difficult job today, because I have just to summarize a little bit the monitoring strategy that we have developed in all this long story of collaboration at the Mediterranean level, and particularly focus on the more recent approach that we have to try to assess the potential impact of microlitter on biota. Even it's clear that comparing the monitoring on beach or the floating litter, monitoring both macro and microlitter, to detect the presence and impact of macro and microplastic on the biodiversity is a very challenging topic. So don't be shy if you have any question or any concern regarding the methodology that we are presenting today. As say from Tommy and from my colleagues, obviously, we have discussed a lot about the presence of microlitter, and particularly of microplastic in the environment. And we try, and I used these verbs, we try to understand the potential effect of microlitter, and particularly microplastic, on marine biodiversity. It's a very challenging topic, both in terms of techniques, but also in terms of try to discriminate how the impact of microlitter and microplastic can be differentiated or not to the massive multiple stress in which the organisms are exposed in the Mediterranean Sea. So today we try to clarify some aspect of the methodology that we have developed in the last decades in collaboration with the different consortium. As previously underlined from my colleagues, Matteo and Dario, we know that microlitter and microplastic strongly impact the biodiversity worldwide. So we have evidence of presence of microplastic starting from planktonic organisms to whales. So this means that is a very massive impact in terms of marine biodiversity. And we have a lot of report in terms of state of art, what can be the species worldwide or the geners more exposed to the impact of macrolitter and microplastic. And obviously, as we have focused with Matteo and Dario, we have some very emblematic bioindicator organisms such as sea turtles, such as marine mammals, and particularly some fish species that can be strongly exposed to the impact of macrolitter and microplastic. And obviously, in relation to the size of the species, the class of the dimension of microlitter can be completely different. Obviously, we can expect a large plastic item in deep diver species such as sperm whale, but we can expect a small microplastic or fiber in invertebrates. Is why we have tried in this multiple presentation to cover all this class of species in terms of biodiversity. But when we focus on the Mediterranean Sea, obviously we are working on one of the area more exposed worldwide of the impact of microlitter. So consequentially, the biodiversity that living in this hotspot of biodiversity worldwide, because you know that the Mediterranean Sea is one of the 25 hotspots of biodiversity worldwide. this biodiversity coexists with one area that is the most exposed worldwide of the presence of marine litter. So we have to integrate this information in order to understand how is critical the problem in the Mediterranean Sea and how is extremely important to develop diagnostic technique to define the presence and the impact of marine litter in the species. Here, just to give some very emphatic information, I report some slide obtained from our lab, and we try to answer to the question, what happened in the Mediterranean Sea concerning the impact on biodiversity. We have 3 charismatic species, such as Tunus, in which we have found some specimens, 7 plastic items. We move on sea turtle, caretta, and in the SPAM, in the protected area of Mediterranean Sea, the Pelagos-Santor, we found some specimens with more than 145 plastic items. But the dramatic case in the med is represented from the sperm whale. In some specimens, we have found more than 20 kilograms of plastic. So it's evident that all the Mediterranean biodiversity is strongly exposed to the presence and consequentially the potential effect of marine litter. And during the all this decade of experience that we have capitalized inside the Plastic Buster initiative, we have tried to develop a more complex methodology in which we put together all the information that we have catch during these learning courses, and particularly one concept that we believe is extremely important. We believe that is extremely useful to have a simultaneous monitoring of the presence of macro and microlitter in the environment and the potential presence and impact of marine litter in biodiversity. So as you have seen in the previous presentation, normally in the project that we have run until now, we are doing simultaneously the monitoring of macro and macrolitter in the environment, and we try to define the potential impact on species. That is particularly important because it's allowed to identify hotspot area for the biodiversity in the Mediterranean Sea, and even to identify the species more exposed to the toxicological risk. And in order to capitalize all this strategy, obviously, as mentioned from Tommy, as report from Matteo, our initiative are taking in extremely important consideration all the strategic elements that are working at Mediterranean level, and particularly the Marine Strategy Framework Directive, and the D10 and the technical group, and Tommy is one of the main actors in this technical group, but even the IMAP indicator of Barcelona Convention that are working in very strong collaboration. But also a lot of projects have worked on this field in the last decade, and what we intend to do in this learning in the project Plastic Buster Cup is try to capitalize all this information and also to try to cover the main gap that we have in the monitoring activity, especially to define the potential impact on biodiversity. And I will try to touch a little bit this concept. But in this context, one of our main goals that we are doing today is to transfer as much as possible all these new achievements at Mediterranean level, because what we would like in the next years is to have the same language at Mediterranean scale in order to have the same approach. And that is exactly what we have done, developing the protocol of marine litter monitoring, and we have already shared with all of you this document but also the fantastic learning modules coordinate from Thomais that I think is very useful tools to capitalize on this approach. And all is reported in the resource pack, in which all documents that we have developed, but they are published for the main initiative at Mediterranean level, are reported, just to give some background information. But coming exactly which we are discussing today, and that is reported in the document that we share with you, is try to understand how it can be the most correct and innovative approach to monitor and assess the effect of marine litter on biodiversity. So what are the novelty that we intend to present today and transfer to you? The novelty is related to one very simple concept. If you want to define the potential impact of marine litter on biodiversity, you have to study the biodiversity. So you have to use as bioindicator organism a wide range of species ranging from invertebrate to marine mammals. And I will try to give some simple example of this approach. There's novelty was developed in the last few years inside the consortium of Plastic Buster. We have published several papers, and the idea is to try to select a series of bioindicator organisms in relation to the habitat and the home range. From this matrix, you can identify several bioindicator species, both for microplastic and for macrolitter, that can range from local scale bioindicators, such as the common mussel that is present everywhere in the Mediterranean Sea, to basin scale bioindicators, such as one of the most charismatic species that we have in the Med, as the fin whale, Balenottera physalus. And so, moving to do this concept, the different habitat, from sea surface, coastal habitat, open water, seafloor, coastal line, and the home range, moving from local scale to small scale, medium scale, and basin scale, you can move for a more complete assessment of the potential impact on biodiversity. And here I'm just coming to show you some new results, a new approach. So, as you know, the Marine Strategy Framework Directive and the IMAP indicator, they have selected as case species or proposed by indicator species from the Mediterranean Sea, the sea turtle Caretta caretta. And obviously, we strongly believe that Caretta caretta is a fantastic bioindicator to detect the presence, especially of macrolitter in the Mediterranean environment. But even if you want really to understand the impact in terms of biodiversity, you have to enlarge largely the number of species to detect it, to investigate, and also to define probably the most impacted species. Is why in the previous project, Plastic Busters, MPAs, we have analyzed more than 46 species ranging from mussel to whales, and analyzed a very large number of specimens, in many cases using a non-destructive approach, as we show later on. And we consolidate very much this technology. So the first novelty is to use a wide range of species in order to define the potential impact on biodiversity. But there is also another novelty in our approach that is coming from the main statement report from Thomais and to Matteo concerning the detection of the ingestion of marine litter on indicator species in the med. And here I report synthetically what is stated from the Marine Strategy Framework Directive that say amount of litter and microlitter ingested by marine animals is at level that does not adversely affect the health of the species, adversely affect the health. And the similar concept is reported also from IMAP indicator. But if you really think about this concept, does not adversely affect the health of the species. Considering the case species, sea turtles, we really believe that the measure of the microplastic or marine litter ingested from these marine organisms can really give the idea of the health of the species. In the last decade, we have developed the idea that is not enough. So the quantification of marine litter ingestion is not enough to define the health of the species. So we need to investigate ecotoxicological effect. We need to understand what happened in terms of transfer of chemicals from plastic to the animals. And we need to understand the effect of the physical harm of plastic and the chemical harm in the species. Is why we have developed this approach that we call threefold monitoring approach. But why we need to do this? Just very small example. This is a very nice review of the last years in which we identified that when a fish species, that Dario and Matteo touched this subject, ingest microplastic, we are able to, as you see, identify how many microplastic can be in presence in the gastrointestinal tract, or large plastic item in a turtles or in a cetacean species. But this plastic, when is ingested from marine organisms, they can generate a different kind of effect. And that the first one is related to the transport of chemicals, because microplastic itself can potentially affect the toxicological health of the organism. For this reason, microplastic on marine litter can have two different toxicological effects. There are some plastic, there are some chemical that we call sorb chemical that can be attached to microplastic and marine litter from seawater. And in this class of chemicals, we have the very well-known polycyclic aromatic hydrocarbons, some insecticide and PCBs, or even some polybrominated diphenyls. But you know that plastic itself can be a carrier of chemicals that we call additives, plastic additives. And so we have this category, huge category of contaminants in which we have bisphenol A, we have a wide range of phthalate, we can have polybrominated diphenyls. So in other words, if these poor fish ingest plastic, they can ingest also chemicals that we can define as plastic tracers. These plastic tracers ingested from a marine organism ranging from mussels to marine mammals can generate a series of toxicological effects in the marine organism, ranging from the potential effect of damage of reaction at molecular level to a series of variation and changing at different level of biological organization, ranging from molecules such as DNA to cell and tissues, to organ, to individuals, to population. All this kind of variation was defined from ecotoxicologists as myself, as Tommy, as Cristina, and so on, as biomarkers. So all this kind of variation, changing that you can measure in a marine organism relate to a class of pollutant or a series of pollutants can be detected and defined as biomarker and represent a first diagnostic test to define the potential effect of chemicals or class of chemicals in a marine organism. I have just give you this very simple background in order to understand when we have to move. So it's for this reason that in the Plastic Buster Consortium, we have developed this approach that we call threefold monitoring approach. The threefold monitoring approach that can be performed in environmental relevant species, such as invertebrate or fish species, have shown from Dario, or even from endangered protected species, such as sea turtles or whale, as report from Matteo, can be investigated at 3 levels of analysis. The first level is the more clear one, the more simple one that was previously described from my colleague. It is represent to the analysis of the gastrointestinal content to evaluate the microlitter ingested by marine organisms. So we have clearly explored with Dario and Matteo how we can detect microplastic and microlitter, how we can characterize all this class of litter in different species. But we have said that is not enough in order to understand the real toxicological effect. So we move in from the step 1 to the step 2, that is the analysis of plastic additive and PBT compound used as plastic tracers. So there are several classes of contaminants, such as phthalate, bisphenol A, PBDs, that can be related to the presence of microlitter ingested in the organism. If you are able to analyze this class of chemicals in the tissues of the marine organism, can represent a really warning sign of exposure to this class of contaminants. But even you can move in a more specialistic way to understand if this class of chemicals and even the physical effect can produce some consequence in the marine organism. Is why you have to analyze the biomarker responses at different levels of biological organization. So 3 steps of analysis in order to answer to the question, the impact on health of species. And this approach was developed and applied in different projects at Mediterranean level. Plastic Buster MPA, Common, UNISI 2, and now we apply with you with the Plastic Buster Cup. Obviously, I have to underline one very important aspect is the concept of the level of expertise. Here we are Mediterranean peoples, scientists, people coming from NGO and so on, and probably we have a very different level of background in terms of analytical approach. So what we intend to do is to present this methodology in terms of level of expertise required. What I would like to say that obviously, if we are talking about the detection of microlitter of microplastic in commercial species, as described from Dario, mussels and fish, I strongly believe that the detection of microlitter microplastic can be done for all of us with a very small specialization. If we move to analyze endangered species, with detection of chemicals and detection also of toxicological effect. Obviously, we need more specialized lab and we need the more specialized techniques. And is why probably we have to approach on this kind of methodology step by step, but also using one thing that I think is very important at the international and Mediterranean level, that is the collaboration between lab. So that is, I think, a very important aspect to identify. So that is a very important point. But apart of this, I would like just to show you in deeply the methods, obviously partially and deeply, because otherwise we need hours, but the potential application of all of these. And I would like just to show the application of the threefold monitoring approach in commercial harvest species, ranging from invertebrate to fish species, and also give you some example of case study of the application of this methodology in endangered species, ranging from sea turtle, seabird, and cetacean. Just to give you an unpublished data that we have obtained from our previous project, Plastic Buster MPAs, here I have the real confirmation of what we say, that really the microplastic can impact the biodiversity in Mediterranean Sea. Here we report 46 species, ranging from invertebrate, elasmobranch, fish species, marine turtle, seabird, and marine mammals, and in more than 95% of the species, we have detected the presence of microplastic. Most of the species have the occurrence around 100%. So it means that in all the specimens, we define the presence of microplastic and marine litter. So that is a very important concept. That means that this species can be useful, used as bioindicator of the health status in the marine environment. But moving to give you some more detailing deeply on the application of this approach on invertebrates. In invertebrates, here we report a case study of the most used species worldwide, that is the Mytilus galloprovincialis, edulis in other part of the world. And here is a very synthetic slide in which we report that all the three steps can be analyzed in the mussels. So the first step is obviously the detection of marine litter, in particular microplastic, and Dario had already given you a lot of detail concerning this. But what I would like to say that in invertebrate species ranging from mussels to crabs to zooplanktonic species to coelenterate like velella, we can also have more specific data, such as the detection of plastic tracers and even the detection of toxicological effect. Here I have reported a symbolic label in which it's very important to understand if during the sampling phase, when you collect your mussel as a report from Dario for the analysis of microlitter ingestion, if you want to perform the biomarker analysis, and I will show you some of that, you have to store the sample in a very proper way that can be in liquid nitrogen, in -18, or even using some extra sampling procedures such as RNA later if you want to do PCR analysis. So that means that also for the sampling phase, you have to use different methodology in terms of analysis. But coming in deeply, we have already seen what happened concerning the detection of plastic, microplastic in mussels. I would like just to focus a little bit on the second category of analysis, that is the plastic tracers. So here we have underlined two different classes of plastic tracers. So the plastic additive itself, and here you can see the methodology to detect phthalate, bisphenol A, and polybrominated diphenyl-ethers. If you want to have future detail on the methodology, you can have a deeply methodological approach in all the link that we have already give you during the presentation. If you want to move on other class of plastic tracers, you can analyze the absorbed contaminants such as polycyclic aromatic hydrocarbon, organochlorine, and even mercury. But if you, your lab is specialized or you have some colleague that can collaborate with you, you can move on the third step of analysis, that is the detection of biomarker responses. And so microplastic and chemicals transported from plastic can generate a series of toxicological effects in a marine organism, ranging from genotoxicity, oxidative stress, immunotoxicity, reproduction alteration, histology and inflammatory modification, xenobiotic biotransformation, neurotoxicity, and cellular stress. Here we have identified the different biological tissues in which you can perform different analytical techniques. All these analytical techniques can be easily evaluated in the different matrix and can give relationship with the presence or not of microplastic. Again, if you want to have more detail, you can check all the RACE park. A very simple case study. Why is important to identify the presence or litter in the environment and the consequence of reaction in the marine organism? Here we have a very simple case study realized in plastic bustard cap, in which we have analyzed the presence of marine litter in different marine protected areas. And here is clear that increasing the concentration of marine litter in the environment, we have an increasing concentration of microplastic in the marine organism. So that is confirmed the validity of a bioindicator species such as Mytilus gallo-provincialis at a small scale. So it's the indicator of what happened in this specific part of the coastal area. But if you want to move in a more specific way, you can analyze, for example, the threefold approach in fish species. And again, I will be very rapid here. We can, in a fish species, have, as report from the video of Dario, you can take the gastrointestinal tract to analyze the presence of macroplastic and microfiber in the ingested from the organism. But even you can collect all this kind of biological material, blood, muscle, gills, liver, kidney, and gonads. And in this kind of biological material, you can analyze plastic tracers, the same list that we have report from invertebrate, and even a wide range of biomarker ranging from the diagnosis of contaminants, marker of immunoresponses, reproduction, and inflammatory morphology. And so this again, with a more complex approach, can really identify the relationship with the impact of marine litter in an area and the potential impact on species. Here again, a very simple case study in which in the different marine protected area, we report the macrolitter in the area increasing in the environment and response to the increasing of occurrence in the species. But if you want to move on the second step, more attractive from an ecotoxicological point of view, the macrolitter in the environment is strongly related on the increasing of phthalate, so plastic additive in the tissues of species. So again, if you move to a more complex analysis, you can identify the impact on health of species. But obviously, a lot of research are developed in the last years, in particular in our group, on charismatic species. And I'm involved, particularly when we touch charismatic species, we are talking about sea turtles, seabirds, and marine mammals. I don't want to talk about sea turtles because we know a lot of things concerning the species. We know that particularly caretta is the common bioindicator used in the Mediterranean Sea, proposed from IMAP indicator and from the marine strategy. And all of us in the MED, we analyze the presence of marine litter, including microplastic in stranded organisms. And we use this data as a report from Matteo to define the presence and impact of marine litter on biodiversity. But we strongly believe, again, that in order to understand the real health status of a caretta, you need to obtain more information, even from the stranded organism in which you can analyze plastic tracers. And we have a very nice correlation between marine litter and plastic tracer in stranded organisms. But what we strongly believe that hospitalized organisms, so the turtles that are recovered in a rescue center all around the Mediterranean Sea, can be a very useful bioindicator to define the health of species. And in this kind of species, you can collect several biological material, such as feces, such as blood, such as skin biopsy. And in all this biological material, you can analyze a wide range of biomarkers. Just to give you an example, in feces, so very easy to collect in an hospitalized sea turtles, we have found a very strong correlation between the presence of marine litter, including microplastic in feces, and the presence of plastic additive and the presence of toxicological effect as porphyrin modification. So even hospitalized organisms can really represent a very important biological information to define the impact on biodiversity. The same approach can be applied in other charismatic species, such as seabirds. Again, you can use stranded organism in which you can measure the presence of plastic itself or plastic additive, but also free-ranging organism, which you can collect blood sample and analyze a huge range of biomarkers. And finally, one of the topics that is more close to my heart, the marine mammals, even pinnipeds, such as monk seal, or cetacean, such as striped dolphin and fin whale, can be used as suitable bioindicator to define the impact on biodiversity. In this case, again, you can focus on two different kinds of sample, stranded organisms, as shown to Matteo, can represent the basis to detect the presence of marine litter in marine organisms, but you can also use this for detect analysis, and also the free-ranging organism using a non-lethal approach that I will show in a minute can be very useful to define the impact on the species. Again, we have the three level, plastic ingestion, plastic traces, biomarker. Obviously, in this case, you have to work or in stranded organisms or using a very specialized analytical procedure that is to obtain skin biopsy to the marine organism. And I will show later on a video that in which you can see how collecting the small skin biopsy can give you a lot of information on the toxicological risk of the organism. But the most conventional approach is what I have already shown from Matteo, so stranded organisms along the Mediterranean coast can be analyzed, even from detect large plastic item, but also to detect microplastic. Here we have a prototype that we have developed in the Plastic Buster project. And in this organism, here we have a Ziphius cavirostri, deep divers that unfortunately have a feeding activity on the canyon. They can eat a wide, very large amount of plastic item. But in this species, you can also analyze a wide range of chemicals. But the more, I think, the specialized technique is the using of skin biopsy approach. And we have used these techniques worldwide, not only in the Med, but in the different sea in the planet. And I would like just to show this very nice case study, just to convince you that whales can be used as bioindicators to define the health status of a marine environment. Here we have an example in which we compare the presence of microplastic in the Mediterranean Sea, particularly in the Pelagos Sanctuary, that is the marine protected area, with an area of control, that is the Sea of Cortez in Mexico. The two areas were analyzed from microplastics, so the presence of microlitter in the environment, and the species were analyzing using the skin biopsy approach. What we obtained here, and we found a dramatic difference in terms of microplastic concentration between the two areas, with very high level in the Mediterranean Sea in comparison to the Sea of Cortez. But what are very interesting that the whales, they have a completely different toxicological risk defined with the presence of plastic additive, with a very high concentration of plastic additive in the whale living in the Mediterranean Sea and high biomarker responses. So that is confirming the idea that that whale can be used as a potential indicator of the health status of the basin. So we have, during this presentation and the training, you have an example of species such as mussel that are spot by indicator of a specific area, and species such as, for example, large filter feeding species such as whale that can be support the monitoring of the entire basin. So that is what is the lesson learned from today and from this experience that we have accumulate all of us in these decades. We strongly believe that the monitoring is a very complex matter, as you see, but we need to have some very clear point. It's very important to have a simultaneous monitoring of marine litter in the environment and the marine litter impact on biota. And that is coming from, for example, monitoring the different compartments. You have seen the monitoring show from Thomais to Cristina, that is clear how the impact is different in the different compartments. And it's very important also to have a simultaneous monitoring of impact on biota and the presence itself. Sometimes, and we think it's very important, we support our research to develop marine litter models that can really help you to define the hotspot area. And we have also used a lot of this approach to define what Thomais defined at the beginning, the threshold level. A lot of the area that we investigate is extremely higher to the threshold level. And all these methodology help us also to define the sources of marine litter. That is always very important. But if you want to come to my job that is define the impact of biodiversity, I strongly support the idea to investigate a wide range of species using a more complex approach that can be the threefold monitoring approach, including endangered species, because they have also a very important role in the ecosystem and a very important role in terms of communication, because say that the whales is exposed to marine litter is strongly impacted the human more than say the mussel is exposed. And finally, that is allowed to define the risk biodiversity prediction, but, and I open the floor to the next day, all this diagnostic approach is extremely important to define mitigation action. So that is, I think, the concept that we have developed during these last years, and we strongly suggest you to use all the material that Tommy have already sent to you, in particular the protocols that we have developed to go in deeply in a lot of this concept that we have presented today, and this fantastic learning produced from MIO and from Tommy that is very, very, very clear, more clear than us probably in explaining all this story. And what we really like at work with all of us at Mediterranean scale in order to achieve the main goal that is in the next year to have the same language to monitor and to mitigate the impact of marine litter in the Mediterranean biodiversity. And if you have 2 minutes, I would like just to show you this video in which a lot of these boring things that I have said you during my presentation are represented to this nice video in which we see how all of us, we have worked in this Plastic Buster project to monitor the presence of marine litter in the environment using all the methodology that Cristina and Tommy have shown you, from the macrolitter to the ROV. You mentioned the ROV, RAV is, this is video from RAV. And how, for example, model can be useful to define the hotspot, and this different procedure to assess and obviously to prevent and finally to mitigate the impact of marine litter. Here we have the microlitter, microplastic sampling. Previously we saw the floating microlitter, but what we are doing in all the stories also to define the impact on charismatic species. And here are the video in which we show how we collect the skin biopsy from the fin whale, and how from this small piece of skin and blubber, we really can define the toxicological risk of the species, from fin whale to mussels, to define the impact on the different and the richness of the Mediterranean Sea. We know it's our hotspot of biodiversity that really we need to preserve. So this is the end of the video, and thank you very much for your attention.
Thank you so much, Cristina. Really, I'm speechless because I couldn't find a better way to recap all the topics that we have been discussing today and touching upon. I mean, the video was a magnificent way to put all of this together. And thank you very much also for your final strong message in terms of marine litter monitoring. Given the fact that I know many of the participants, I fully understand that not for everyone what was presented here in terms of methodological approaches is not for everyone, obviously, depending on the different capacities. I don't know, NGOs can deal more with all types of macrolitter monitoring, divers with seafloor litter monitoring, educational institutes. Again, they can focus more on macrolitter monitoring in the different marine compartments, while the research institutes can go deeper and they can apply all these more sophisticated and more demanding approaches in order to, on the one hand, assess the presence of marine litter and on the other hand, the effects. So Thank you very much. I would like now to go to some questions. And first of all, to thank all of the participants for the very encouraging comments that they have been posting. We are happy that you find all these presentations informative and interesting. And we will share these presentations at the end of the webinar and the e-course for sure. And now I think, let me see, there was, first of all, there was a question to express the results of marine litter in fish. Is it given by individual number of items per individual or by weight of mass? This is the question. I think that Matteo can respond to that question.
I think Dario already responded in the chat.
He did.
Right, Dario? I'm here. We are in the same room.
Okay, but maybe he can repeat it because we have many questions. Okay. And then the second question was about the standard maximum concentration of marine litter in biota. Perhaps I can respond to that there is no threshold yet defined for marine litter in biota. The only threshold that we have defined is for beach litter, and it was already complicated enough, but currently, at least at European level, I'm not sure whether at international level there are similar efforts for defining thresholds, but at European level, we're working now for defining thresholds on floating litter and seafloor litter, and eventually for microplastics. And at some point, of course, we will go to biota as well. Yeah, but it's quite difficult.
I would like just underline what you say. Obviously, it's extremely difficult. And the only point that I can add that at the moment, the UNEP map are working, try to define a potential threshold for sea turtles. They are working, collecting all the data, reporting on the Mediterranean Sea, and they try to report a potential threshold for sea turtle. But even, I think we are very far away from this.
Another question was whether we can use ascidians as a species for the threefold monitoring approach, but they're easy to sample and they don't require some kind of a permit. I don't know who would like ascidians. Right. I don't know. Have you?
No, I think there are data. Probably a huge number of species already investigate. Even as we have collected some ascidian species during our sampling activity. Obviously, as we say, the different species in terms of home range and geographical distribution can be informative for our goal. So no problem to use also these kind of species.
Right. And now, as much as I can see, there are no further questions. So I'm glad it seems that things were quite clear, but nevertheless, as Dario posted his email for further questions, I will share with you, if Cristina and Matteo don't object, I will share all of our emails. So feel free, depending on the kind of presentation, to ask a question, to send us emails with your questions. We would be happy to respond to them. So I would like to thank you all for joining us. We're really honored with your very dynamic participation, I have to say, and also to thank our interpreters for bearing with us. We are maybe not the easiest speakers on planet Earth. And we are looking forward to seeing you again on Thursday's webinar that will focus more on how all this fit-for-purpose data can fit into the identification and operationalization of marine litter prevention and mitigation measures. And from my side, to wish you a lovely day, rest of the day, and also perhaps if Cristina would like to make the closing, the official closing of this webinar.
Thank you very much. Bye-bye. Thank you, Tommy, for everything. And thank you for the speakers and for the
Thank you all.
interpreters.
My own. Thanks, Cristina.
Thank you all, guys. Lovely seeing you. Bye-bye.
Ciao.
Bye-bye.
Ciao. Bye. Bye-bye.